In this video, we are going to do a lot of examples about normal distribution. This is the first example. So a normal curve is given, and you need to find the area less than z equals to 1.43. You need to look up the z equals 1.43 in a normal table. Here is a normal table. In your exam, a normal table will be provided. So we are looking for the area for z equals 1.43. And the area is from left to right. So in the columns, these columns, we can identify the first decimal, 1.4, which is here. And in the row here, we're going to find the second decimal, 0.03 here. Then we will locate the area, which is 0.92364. In your exam, you may need to enter this number, or I will design a multiple choice. Then you just select the correct option. So the area from negative infinity to z equals 1.43 is 0.9236. In your next exam, you may need to find the area greater than z equals to negative 0.08. However, remember that the normal table always provides area less than z equals something or some number. What you can do is you find the area of this transparent area first, then use 1 subtract the transparent area, then you get the area greater than z equal negative 0.08. So again, I will show you how to find area less than negative 0.08. So you use the first column to identify the first decimal place. So do not forget the negative sign here. Okay, there is a negative sign here. So in your exam, I may provide you a complete normal table, including the positive value and negative values. Remember that you don't want to look at the wrong table. Then you need to find the second decimal place in the first row. So the corresponding area is this number. Remember that when you look at the normal table, you want to know that the value represents area to left or to right. Most of the time, the normal table will represent area to the left of the z-score. For a normal table, we have that area to left equals to this number. Then we can just calculate the area greater than z equals negative 0.08 as 1 subtract 0.4681. This is a more challenging question. For a normal table, we can have the area to left equals to this number. And remember from the first example, the area less than 1.43 is this number. This means so this area equals to 0.4681. This area equals to 0.9236. So the area between them is using this number, this area, subtract this area. So that's why we subtract these two numbers. Here's another one. Find the area less than z equals to negative 0.08 and greater than z equals to 1.43. So from the normal table, we have the area less than negative 0.08 is this number. And we have the area less than 1.43 is this number. So the area greater than 1.43 should be used 1 subtract by 0.9236, which is the right shaded area. So the total area shaded will be summation of these two numbers. Here's another type of question you need to know how to answer. So in your exam, you may need to find the value of z given a probability. So basically, we work backwards in the table. Now we know the probability or the values in the middle of the table, and we want to find the corresponding z value. Here is another example. Find the value of z that represents the probability of 0.4013 of the area is less than yet. Because the probability is 0.4 something, which is less than 0.5, and it is of the data less than z score. So the vertical bar will locate at the left side of the normal curve. Because it locates at the left side, we know that the z-score is negative. Next step to do is look for 0.4013 in the middle of the normal table and find the corresponding z value. We find the 0.4013 is just the rounding. Then we can use the first column to locate the first decimal place for z-score and use the first row to locate the second decimal place of z-score. So the z-score should be negative 0.2 plus 0.05 as you see. This should be the correct answer. This question is more challenging than the last one. Find the value of z that represents the probability of 0.0436 of the data is greater than yet. We know that z is positive because we need the area greater than to be less than 0.5. Remember that normal table always records the z-score corresponding to the area less than something. So you need to calculate the area less than this vertical bar, which should be calculated in this way. After you have the area of the transparent place, you can find the corresponding z value in the normal table. This is the closest z value we can find. Again, we use the first column to locate the first decimal place and the first row to locate the second decimal place. That's why the z-value is 1.71. Here is a review of a normal curve. Normal curve is always symmetric and bell-shaped. Second, the total area under the curve always equal 1. For normal distribution, mean should equal median because it is symmetric, and they fall in the middle of the curve. Therefore, area under the curve less than the mean and area under the curve more than the mean all equals to 0.5. The area under the curve is used to find the probabilities. Here is a review of z and a normal table. If we know mu and sigma, we can calculate the z-score for any value of x. We use z-score to look up the area to the left of z in the normal table. If z equals 0, it means it is at the mean or middle of the curve. For any value less than mu, z is negative. For any value greater than mu, z is positive. Normal table will always give you area less than z. So if you need an area greater than z, then you do 1 subtract shaded area. Here are two types of questions you need to understand. If we have x, the value of a random variable, how can we figure out the number of standard deviations it falls from the mean of its probability distribution? You can calculate the z-score. If you are given x and need to find the probability, first, you convert x to a z-score. Then you use normal table to find the probability related to the value. If you are given the probability and want to find x, first you convert the probability to relative cumulative probability. Then you find the z-score using the normal table. Last, you evaluate x equal mu plus z times sigma. This is an example from your textbook. Suppose your favorite coffee machine offers 12 ounces cups of coffee. The actual amount of coffee put in cup by the machine varies according to a normal distribution, with mean equal to 13 ounces and the standard deviation equal to 0.6 ounces. For each question below, sketch a graph, mark the mean, shade the area to which the answer refers, and compute the percentage. A typical question will be, what percent of cups will be more than certain ounces or less than certain ounces? The problem and the information we are given tells us which steps we need to follow. First, we know normal with mu equals 13 and sigma equals 0.6. After we know this information, we can sketch a bell curve with central located on x equals 13. We also know that some characteristic of x we are interested in tells us where to draw a vertical line and which way to shade. I'll explain in next slide about this sentence. Next, to use the normal table, we need to convert x to a z-score. Last, we need to look up the z-score in the table and find the shaded area. A particular question could be, what percentage of cups will be filled with less than 12 ounces? As we know, the mean equals 13. It means the peaks of normal distribution located at x equals 13. We are interested in what percentage of cups will be filled with less than 12 ounces. So that's why we should sketch the vertical line at x equals 12. Since it is less than 12 ounces, the left part should be the shaded area. Next, we want to convert x to a z-score. Simply use the z-score formula. We can have z-score equals negative 1.71 1.67. Then you can look up the negative 1.67 in the normal table. We can find that the shaded area equals 0.0475. This means the shaded total area equals to the probability of x less than 12 equals to this number, which is 4.75%. Another type of question will be asked is, what percentage of cups will be filled with more than 12.5 ounces? Again, we can put 13 here and 12.5 on the x-axis. Since we are interested in what percentage of cups will be filled with more than 12.5 ounces, so the right part should be the shaded area. Next, we want to convert x to a z-score. Use the same formula. We have z-score equals negative 0.83. Then we look up the negative 0.83 in the normal table. Remember that the normal table gives us the area to the left, which equals to 0.2033. Because the area under the curve, the total area under the curve is 1, we simply use 1 subtract 0.2033 and we have the shaded area here. So the shaded total area will be the probability of x larger than 12.5 equals to this number, which is 79.67%. Here is another type of question you may be asked during your exam too. What percentage of cups will have in between 12 and 13 ounces of coffee? So first step, we convert x to a z-score. First, we want to convert z-score that for x equals 13. According to this formula, the z-score responding to x equals 13 is 0. Second, we need to convert when x equals 12. We want to calculate the z-score for x equals 12. Using the same formula, we have the z-score corresponding to x equals 12, which is negative 1.67. Then we look at the normal table. When z equals 0, the shaded area should equal 0.5. When z equals negative 1.67, the shaded area to the left will be this number. So the shaded area we are looking for will be the difference between this number and the transparent area. In other words, the probability that cups of coffee will have in between 12 and 13 ounces equals to this number. Here is another example from your textbook. You can pause this video and read the question. What proportion of children has an MDR at least 120? This question is equivalent to what is the probability of x larger than or equal to 120? This probability also equals to the probability of x larger than 120. This is because for continuous probability distribution, the x equals a single point, for example 120, equals 0. Because we are interested in at least 120, the right part will be the shaded area. In order to use the normal table to find the area to the left, we have to convert x to a z-score. Again, this calculation is exactly what we did in previous examples. Now we have convert x to z-score. We look up the 1.25 in the normal table. Then we can find the area to the left equals to this number. It means the shaded area should be calculated as 1 minus 0.8944, which equals to this number here. Very similarly, we can answer this question. What proportion of children has an MDR at least 80? Remember that the normal distribution has a mean of 100. The 80 should be on the left side of 100 here. Because we are interested in at least 80, that's why the right part will be the shaded area. Next, we convert x to a z-score. Then you look up the negative 1.25 in the normal table. Then you have the area to the left. Then you calculate the shaded area, use 1 minus the area to the left. Another type of question will be, find the MDR score that is 99th percentile. The 99th percentile tells us the given shaded area equals 0.99. So if you know the shaded area to the left of some vertical line, then you can use normal table to find the corresponding z-score. The z-score should equal to 2.33. Then you need to convert z-score to its original scale, x. That's why the x should be calculated in this way. A modified question could be, find the MDR score such that only 10% of population has MDR above it. So the given shaded area equals 0.1. Then we still need to find the shaded area to the left, which could be calculated as this way. The transparent area will be 0.9. If you know the shaded area to the left of some vertical line, then you can use the normal table to find the corresponding z-score. We find the z-score equals 1.28. Last, we need to transfer the z-score to its original scale, x, which should be calculated in this way. This is the last example of this video. It is from your textbook about empirical rule. Verify using the normal table that for a normal distribution, the probability within one standard deviation of a mean equals to 0.68. The sentence within one standard deviation of the mean tells us we need to use z-score equals -1 and the +1. Remember that z is just the number of standard deviations from the mean. We look up the z equals -1 in the normal table. It tells us the area to the left is this number, which is the transparent area. Then we look up the z equals +1 in the normal table. It tells us the area less than this vertical line is this number. So the shaded area should be calculated as the area less than z equal positive 1 minus the area less than z equal negative 1, which is this number.